Hey, today I'm going to be talking about sight, and in this video I'm going to focus mainly on how your eye focuses light onto the back of your retina and the processes that go along with that. So first of all, let's go over some anatomy. In this rudimentary drawing of your eye, you have a lens, and then you have your cornea on the outside. The cornea is that clear window, the very outside of your eye, which is a clear window letting light in, right? So the cornea, what it's going to do is light's going to hit it, and the cornea does most of the bending of light through refraction. So if light hits the edge of the cornea at an angle to the cornea, then the cornea is going to bend it. But if it hits it straight on at a 90-degree angle, you're going to be fine, and it's going to go straight through. Once you've bent it the first time via the cornea, it's going to hit the lens, and the lens will make minute adjustments such that the light focuses onto the back of your eye or the retina, and the light will converge to what is called the focal point, and that's all made possible by the bending, the refraction done by the cornea and the lens. So the cornea doesn't adjust. Light just hits it, and whatever happens, it bends it. That's how the cornea works. But for the lens, it can adjust depending on where we want to put our focal point on the eye. So the way that the lens does that is you have a shape kind of like this. It's convex on both sides. So when you spread out the lens, it's going to be flat. But then when you relax it, it's going to be convex like this. So the way it does that spreading and relaxing into the convex shape is through something called the ciliary body. So the ciliary body is composed of a ciliary muscle, and that's sphincter-like. It goes around the whole eye or the whole lens. And then you have ciliary processes, which are, you have suspensory ligaments which attach the ciliary muscle to the lens. And what that does is those ligaments, if you need to pull on them, let's go over what the ciliary muscle does. When the ciliary muscle, which surrounds the lens, is relaxed, it's pulled taut, so your lens is going to be flat. But then when the ciliary muscle constricts, it pulls closer, which relaxes those suspensory ligaments, which if you pull it closer, then your lens goes convex, right? There's another part of that, which would be your ciliary processes, which those secrete aqueous humor, and that's just a fluid that is found in the anterior cavity of the eye between your cornea and your lens. There are two chambers to that, but that's outside the scope of what I wanted to talk about today. And so that's how your suspensory ligaments and your ciliary muscle are going to control the conformation of your lens, whether it be relaxed and convex or relaxed and flat. If your muscles are relaxed, they pull out on the suspensory ligaments, flattening that lens. But if you contract the ciliary muscle, they are sphincter-like, they're going to go closer, and then that's allowing the suspensory ligaments to move closer and make it convex. Convex. Okay, so with that in mind, this is all just to help us focus objects onto our retina, because it all has to hit at a certain point on the retina. So you have to adjust the front part of your eye, the lens and such, so that you can focus it back onto that back part of the eye. There are a couple ways it does this is through the thickening of your lens, which is called accommodation. I kind of went over it. It's when you contract the ciliary muscle and the lens becomes convex. So that's one way, and what that does with the thickening of the lens, it allows the light to bend more because it has more lens to go through. And so what that will do is make this focal point closer or more shallow towards the lens. Another way that we focus on things that are up close, sometimes you max out, you can't relax the lens anymore, and so your eyes will converge to make an object close to you more visible. So if I do this, it gets blurry if I don't move my eyes, but if I go cross-eyed, then I can see my finger. That's just with the convergence of your eyes. And then another way is the constriction of your pupils. So your pupils are that dark circle you can see in my eyes. And that allows more light in or less light in. If you're up close, your pupils are going to constrict, which means they get tighter, and so you're allowing less light in. So what does that do? That increases our depth of focus on our close objects, so we can focus better on close objects. So the pupils getting smaller, we can focus better. But what does that mean? We're allowing less light in because our pupils are constricted. And so with close-up objects, we're allowing less light in, so we might have to illuminate the object more. So we might need to shine a light on whatever we're focusing on up close. So essentially, that's how we focus light onto the back of our retina. And it's all dependent upon refraction of light and how your lens will adjust it. And there are also other ways, depending on the amount of light, that your eye will accommodate it so you can actually see things up close, or the opposite thereof, so you can see things far away. So you'll dilate your eyes looking far away and to allow more light in, and you'll flatten your disc so you lengthen this focal point so that you can see farther. The more flat your disc, the less refraction will occur. So that is how we focus light via the ciliary body and the lens and the cornea.